Hi, I'm Francesco Santini, and this is my physics lab report. The aim for this lab is to create a computational model that can describe the motion, which is shown from this video, which shows a mass tied to a spring that oscillates in both a circular motion and also oscillates on the spring. The principles that were applied were Newton's second law of kinematics, which is this one, and the energy principle that describes that energy in a system is conserved and exchanged between the system and the surroundings as work. The computational model will be based upon Newton's second law, and the energy principle will be used to validate the computational model. The net force on the mass will be the weight force and the spring force. But to compute the spring force, we will need the spring constant and the relaxed length, which will be L0, in order to determine the stretch S. And this is how to determine the spring constant. And on this slide over here, you can see how the relaxed length of the spring will be determined. In order to create a computational model, the energies will be taken into consideration. And the energies that will be taken into consideration will be the kinetic energy of the mass, the spring potential energy, and the gravitational potential energy. And these are the following equations that will be applied. The net force from the code will be determined as the sum between the weight force F grav plus the spring force. And then through Newton's second law of kinematics, both the velocity of the ball and the position of the ball and the stretch will be updated. And then afterwards, these new data will be plugged into the new data of energy. And afterwards, the changes in kinetic, gravitational potential, and spring potential will be calculated. And also the energies and the changes in energy and their sum will be depicted through this following graph. Then the model will be run. The red ball depicts the position of the ball with the tracker data. The blue ball depicts the ball from the computational model. And also this graph shows the comparison between the red sphere and the blue sphere. And at last, this graph shows the changes in energy with respect to time. The blue line shows the change in kinetic energy. The red line shows the change in spring potential energy. The green line shows the change in gravitational potential energy. And the yellow line shows the total energy change. And let us discuss about what does it mean questions. At first, we have to discuss whether the fundamental principle of the energy principle was conserved. And yes, it was, because the computational model does fulfill the energy principle. Because from the graph created with Python, you can notice that the change in energy total change in energy is always equal to 0. And therefore, the value of energy has to always be a non-zero value. The reason why the change in energy is 0 is because the system taken into consideration is comprised of the earth, the mass, and the spring. And the forces that are acting are all within the system, and therefore there are any interactions between the system and the surroundings, which would cause the system to lose energy. And then, let us first evaluate a little bit about the periods of oscillation. In the x direction, the period of oscillation is 1.61 seconds. And in the y direction, it is 1.519 seconds. All this was determined through tracker, with these graphs which are sine and cosine, which every single bump will be depicted as the interval, as the period of interval. The reason why they are different is because on the y direction, this equation is working, and on the x direction, this following equation is working. And for them to be the same, that's be impossible, because the values under the square root are completely different. This is my lab report.